Welcome to another session of Ebenezer GATE coaching classes. This is a problem that appeared in GATE 2012 for 1 mark. It is a multiple choice question. A transmission line with a characteristic impedance of 100 ohm is used to match a 50 ohm section to a 200 ohm section. If the matching is to be done both at 429 megahertz and 1 gigahertz, the length of the transmission line can be approximately, there are 4 options. Actually, there is a mistake in this print of the question. So the first choice A is 82.5 centimeter, whereas the other choices are not in centimeter, they are in meters. So now let us find out what is the wavelength at 429 megahertz and 1 gigahertz. So lambda 1 is C by F1. C is 3 into 10 power 8 meters per second divided by F1 is 429 into 10 power 6 watts. So it is actually 300 by 429 meters. In other words, it is 0.7 meters. Lambda 2 is C by F2. So it is 3 into 10 power 8 meters per second divided by 1 gigahertz. That is 1 into 10 power 9 hertz, which is 0.3 meters. Now, we have a transmission line with a characteristic impedance of 100 ohm, which is used for matching a 50 ohm section. So we have a transmission line which is 50 ohm transmission. And you're going to match this with another transmission line which is 200 ohm. So in between you have this 100 ohm transmission. Normally we use a quarter wave transformer, which is this 100 ohm transmission line. So the relationship should be a quarter wave. So it should be lambda by 4 or an odd multiple of lambda. So we know that 50 Zn is equal to Z0 squared by ZL. And here Z0 is 100 of the quarter wave transformer, 100 square, 100 into 100 divided by ZL is 200. So 200, you get 100 by 2, which is 50 ohm. So we are able to match this 50 ohm line with the 200 ohm line by having a quarter wave transformer of 100 ohm. And we find that the input impedance at the input of which acts as a load here is also 50 ohm, and there is a perfect match. For that, the length of this 100 ohm transmission line should be an odd multiple of lambda by 4. Now, we have lambda 1 is it should be matching for both the frequencies 429 megahertz and 1 gigahertz. That is, it should match for lambda 1 as well as lambda 2. So to find out what should be the length where it is matching for both the frequencies, first of all, we should have a common wavelength. So we can find the LCM of lambda 1 and lambda 2. And we know that the LCM of lambda 1 and lambda 2 is 2.1 meters. That is 3 times lambda 1 is 2.1 meter and 7 times lambda 2 is 2.1 meter. So if we have 2.1 meter, then the length, if you have a length of 2.1 meter, then both the lambdas are 2.1 meter is a multiple of both lambda 1 and lambda. So the length should be an odd multiple of 2.1 by if you have 7 times, this will be 7 lambda. You divide by 4, it will be 3, sorry. In case of 2.1 meter by 4, it is actually 3 lambda by 4 here. And here it is 7 lambda. So both the cases, it is an odd multiple of lambda by 4. Okay. And then odd multiple of that will again be an odd multiple of lambda by 4. So we have 2.1 by 4 is actually 0.525. There is no option of 0.525. We multiply 0.525 by 3, we get 1.575, which is almost 1.58. So the option is C, where there is perfect matching if the length of the 100 ohm transmission line is 1.58 meters. The option is C. Thank you. God bless you.